This is it, last new lesson of the semester for Algebra 2. Quadratic models. So we've done several things with quadratic models. First of all, we did things where I gave you a quadratic equation, population, fruit flies, mosquitoes or something, and you answered questions. Then I gave you data points, and you created the quadratic equation, and I asked you questions. Then we did projectile motion, everything that deals with -1/2 gt squared plus initial velocity times time plus initial height. Then we dealt with problems that have borders like picture frames. And then the last one is problems that deal with fences, okay? So let's just take a look. It's similar to borders, but a little bit different. With the fencing, typically the scenario is you've got a certain amount of fence, okay? Whereas with borders, you had a certain amount of area to work with. So the difference here is in borders, I was dealing with the area of a border, but in fences, I'm dealing with the amount of material or the perimeter of the fence, okay? So let's take a look. Mr. Sherwood is going to fence in his part of his yard. He's going to use the back of his house as one side of the fence. If he has 500 feet of fencing to use, what dimensions would create the largest enclosed possible area? Okay, so to get the largest enclosed possible area. So let's look at this. Now, when you see something like this, when you look at this fence, two sides of this fence are equal to each other. That is the best place to let your variable x be, okay? I know that those two are the same, okay? So I know that x is that side of the fence. Now, the side of the fence here, I'm not sure what that is, okay? That's another side of the fence, okay? But what do I know? How much fencing do I have? I've got 500 feet of fencing, so you know that 2x plus y has to equal 500. So that means that y has to equal 500 minus 2x. So I now know that this side is 500 minus 2x. So those are the dimensions of my fence. X is one side, x is the other side that opposing, and then 500 minus 2x. So the area of this fence, so the area is equal to x times 500 minus 2x. That is the area of the fenced-in region. So if I look at this, the area, let's just call it A, is going to be 500x minus 2x squared. Let's rewrite this. The area is equal to minus 2x squared plus 500x. That's the equation. If I were to graph that, what's that equation? That is the equation of a parabola. It's a parabola that opens which way? Hopefully you said down. So this is a downward opening parabola. How would I find its maximum? That's just code for where is the vertex, okay? The vertex is going to be at x equal what? Negative b over 2a. So this is going to be 500 over 4, which is what? 250 over 2, which is 125, okay? So that tells me the dimensions of this, that tells me that this side is 125 feet, this side is 125 feet, okay? And then what's the remaining side? The remaining side here is 500 minus 2 times 125, so this is 250. So this fence is 125 by 250. That is the way that this fence will have the largest area. So this was a little bit different. So I did not have to use C-poly roots. So I came up with an equation for the area. And if I'm trying to maximize the area, well, if that's a downward opening parabola, the maximum occurs at the vertex. So let's just find the vertex, okay? How would this problem differ if the fence were 4 sides, okay? So something very similar, let's just go ahead and say, okay, these two sides are x, okay? The other side that I don't know, well, I know that they match, okay? Then what do I know here? I know that 2x plus 2y is equal to how much fencing do I have? So I had 500 feet of fencing. So I know that 2y is equal to 500 minus 2x. Therefore, y is equal to 500 minus 2x over 2. Y is equal to 250 minus x. So this side is 250 minus x, and this side is 250 minus x. What is the area of this rectangle? Area is equal to x times 250 minus x. Area equals 250x minus x squared. Area equals minus x squared plus 250x. That's a parabola that opens downward. If my goal is to maximize that area, I need to go find the vertex. The vertex is going to be x equal negative b over 2 times a. So this is 125. So that tells me that this side is 125, this side is 125, and then 250 minus 125, this side is 125, and this side is 125. So that is really a square. So the dimensions here are 125 by 125 if I had a four-sided fence, okay? Look at another example. A rectangular patio is surrounded on three sides by a fence. So you've got some kind of patio. It's surrounded on three sides by a fence, okay? If the patio area is 150 square feet and the total length of the fence is 35, what is the length and width of the patio, okay? So if you look at this, you typically would come in and say, okay, the two sides that match, let's let those be x. This one is going to be y, okay? So in this case, if you look at this, you know that 2x plus y has to equal, how much fence do you have? 35 feet. So y is equal to 35 minus 2x. So this side is 35 minus 2x. Now, they tell me that the area of the patio is what? The area of the patio is 150 square feet, and they're wanting for me to know the length and width of this patio, okay? So I know that the area of this patio is going to be x times 35 minus 2x. So this means that the area is 35x minus 2x squared. But I know that the area is 150 square feet, so 35x minus 2 x squared has to equal 150. So this is a quadratic equation. Negative 2x squared plus 35x minus 150 equals 0. I waste no time in going straight to my calculator for this one. So menu algebra, complex roots. So minus 2x squared, and then what was it? Plus 35x minus 150 plus 35x minus 150. That has been set equal to 0, so solve that for x. X is 15 halves and 10. So I get x is equal to 15 over 2, or 10, okay? So what does this mean, okay? So what is the length and width of this patio? So let's start with x equal 10. So if x were equal to 10, this would be 10, 10, and then this side would be 35 minus 2 times 10, 35 minus 20 would be 15. So this could be a 10 by 15 patio. That works because that gives me 150 square feet. Let's look at what happened if it were 15 halves. So 15 halves, you would have, if you had 15 halves here and 15 halves here, then this remaining side would be 35 minus 2 times 15 halves. This is 35 minus 15, which is 20. So you could have 15 halves by 20 could be the dimensions of this particular one, and that would also give you 150 feet. So I got two choices here. Those are the two choices for the dimensions of this particular patio based on this example. So this one was different. I did not say maximize the area. I said, what are the length and width, okay? If I needed to maximize the area, that would be a different problem finding the vertex. But this one, I gave you a specific area. So it was already fixed, and you had to figure out what the dimensions were that make that happen. What if the fencing were four sides on this problem? So if I created a four-sided fence in this problem, X, X, Y, and Y, you know that 2X plus 2Y is equal to the 35 feet of fencing that I have. So 2Y is equal to 35 minus 2X. Y is equal to 35 minus 2X over 2. So that means that this side here is 35 minus 2X over 2. This side, 35 minus 2X over 2. Now, what is the area of this patio? The area of this patio is X times 35 minus 2X over 2. And we said that the area is equal to 150. So that means that the area is going to be, so when you multiply all of this out, let's just go ahead and write this as area equal X. Let's write this as 35 over 2 minus X. So area is going to be 35 over 2X minus X squared. Set that equal to 150. So minus X squared plus 35 over 2X equals 150. Minus X squared plus 35 over 2X minus 150 equals 0. And then just go to my calculator, and in order to solve this, menu, algebra, complex roots. So this equation was what? Minus X squared. So minus X squared plus, this is 35 divided by 2X minus 150, and solve that for X. And what kind of numbers am I getting there? Okay, I'm getting complex numbers here. Okay, so when I see this, complex numbers, can the side of one of these patios be a complex number? Okay, in this case, there are no real solutions here. What it means is, with 35 feet of fencing, you cannot build this particular patio. You can't build a patio of 150 square feet if you only have 35 feet of fencing. It's just not possible to make that happen, okay? So there's no real solution here. It can't be done with four sides. A farmer has 1,500 feet of fence in which to fence a rectangular plot of land that borders a river. Find the largest area that can be fenced. So I have a river and I have a fence, okay? Now the key to it is, if you see anything that has the same variable, like this side, let that be X. This side is going to be Y. You know that you only have 1,500 feet of fencing. So 2X plus Y has to equal 1,500. So y has to be 1500 minus 2x. So this side is 1500 minus 2x. I'm trying to maximize the area. What is the area? The area is equal to x times 1500 minus 2x. So the area is 1500x minus 2x squared. So minus 2x squared plus 1500. That's a parabola that opens downward. To find its maximum means to find the vertex. So x is equal to negative b over 2a. So that's going to be negative 1500 over 2 times negative 2. And so this is going to be 1500 over 4, which is what? 750 over 2, which is 375. So what does that tell me? It tells me that this side is 375, this side is 375, and then this side here is 1500 minus 2 times 375. This side is 750. So your fence is 375 minus, 375 by 750. So that is the dimensions of this, okay? So find the largest area that can be fenced, okay? That's different than the dimensions of the fence with the largest area. So this would tell me this is the dimensions. What is this area? So then you just multiply this out, 375. So 375 times 750 is 281, 250. So 281, 250 square feet. That is the largest area that can be fenced in this particular scenario. A 400 meters of fences encloses a rectangular field having an area of 800 square meters. Find the dimensions of the field. Okay, so I've got a fence that encloses a rectangular field, so like a football field. So you got a fence that goes around a football field. So you've got X and X, Y and Y. You know that you have 400 meters. So 2X plus 2Y is equal to 400. That means that 2Y is 400 minus 2X. Y is equal to 400 minus 2X over 2. Y is equal to 200 minus X. So this side is 200 minus X, and this side is 200 minus X. Okay. What is the area of this field? The area is going to be X times 200 minus X. I know that the area is 8,000. So you have X times 200 minus X equal 8,000. This means that 200X minus X squared equal 8,000. Therefore, minus X squared plus 200X minus 8,000 is equal to 0. So go to your calculator here and menu complex roots. So this was minus X squared. And what is it? Plus 200 minus 8,000 plus 200X minus 8,000, and solve that for X. So I get two numbers here, 55.27, we'll just say 50, we'll call it 55.28. So X is equal to 55.28, and X is equal to 144.72. So 144.72 144.72. And now I just have to make sure that both of these make sense, okay? So if x is equal to 55.28, so let's take the first case. That means this field would be 55.28. And then what is your y value? Your y value is going to be 200 minus that. So 200 minus 55.28. So 200 minus 55.28, 144.72. So it's 55.28 by 144.72. Okay? If you were to use the other value for x, when x is equal to 144.72, then you know that y is going to be 200 minus that, and that's going to be equal to 55.28. So you get the same dimensions. There's only one possibility here, okay? Even though I got two answers, they worked out to giving me the same dimensions of the field, okay? So 55.28 by 144.72 would be the dimensions. And that should take us up into the homework.